In 2013, Boeing made a decision that looks boring on paper but changed a lot of things in the real world. They picked one engine, the GE9X, to power their newest wide-body jet, the 777X. Sound small? It wasn't. That single choice affected engineering design, airline bills, factory floors, and who would make money for decades. Think of it like choosing the engine for a city's bus system. If the city picks a familiar diesel supplier, mechanics already know how to fix it. Parts are nearby, and routes keep running. If the city bets on a brand new electric motor that's more efficient but unproven, buses might be quieter and cheaper to run, but only if the technology works and if the chargers get installed on time. Boeing faced the same trade-off: proven, integrated performance from GE versus a promising but immature design from Rolls-Royce. Why does this matter to anyone who isn't an airplane nerd? Because engines aren't just bolts and turbines. For airlines, engines are one of the biggest ongoing costs. Fuel use, regular overhauls, spare parts, and trained mechanics. For the manufacturer, exclusive engine deals mean long-term aftermarket revenue. Companies make as much or more from servicing engines over their life than from the first sale. For Boeing, choosing GE meant less technical risk and faster program timelines. Waiting for a new Rolls-Royce technology could have delayed the whole plane. That's the stake. Boeing wasn't just buying hardware. They were betting on speed to market, predictable performance, and who would control the long tail of profits. To see why GE looked like the safer bet, we need to dig into what Boeing actually required from the 777X engine, the power, efficiency, and scale that made this decision so high stakes. To understand why Boeing leaned so heavily toward GE, imagine you're building a brand new supercar. You don't just need an engine that works. You need one that can handle extreme speeds, stay reliable, and run cheaper than competing models. Boeing's challenge with the 777X was very similar. The 777X wasn't designed to be just another jet. It was supposed to replace the aging 777-300ER, one of the most successful long-haul aircraft ever built. That meant the engine had to hit three huge requirements. First, massive thrust, enough to lift the world's largest twin-engine jet. The 777X is huge. Its wingspan is so wide it needs folding wingtips just to fit at airport gates. A plane this size needs engines that can produce over 100,000 pounds of thrust. That's like the force of a dozen diesel locomotives working all at once. Only a few engines in history have reached that level. Second, better fuel efficiency. At least 10% improvement over the old model. Fuel is the biggest operating cost in long-haul aviation. Boeing promised airlines the 777X would burn significantly less fuel per seat than the 777-300ER. That required an engine with a giant fan, new materials, and cutting-edge aerodynamics to squeeze every drop of efficiency out of the design. Third, reliability from day one. No risky delays. When airlines buy a plane, they're not just buying metal. They're buying a schedule. If the engine is late, the whole plane is late. Boeing was already struggling with delays across multiple programs, so the 777X needed an engine that would be ready on time and wouldn't become another high-profile setback. These requirements weren't optional. They were the entire business case of the 777X. Any engine with unproven technology was automatically a risk, and that's where the two competing philosophies became clear. GE offered evolutionary improvements, while Rolls-Royce was preparing a revolutionary but not yet ready design. That's the setup for the next part, what Rolls-Royce brought to the table, and why it changed the entire decision. Rolls-Royce did not come to the table empty-handed. In fact, they came with one of the boldest concepts in modern engine history, a radical new family of engines called the Advance, and later, the even more ambitious Ultrafan. These weren't small upgrades, they were tear up the rulebook and start again designs. Here's what Rolls-Royce was promising Boeing at the time. First, a new core that could push efficiency far beyond existing engines. Rolls-Royce had developed a lean burn combustion system and ceramic matrix composites, fancy materials that stay strong at extreme heat but weigh less than metal. On paper, this meant an engine that could run hotter, last longer, and burn less fuel. Think of it like switching from steel parts to carbon fiber in a race car: lighter, tougher, more efficient. Second, a gearbox on a giant turbofan, the technology of the future. Rolls-Royce was aiming to build the world's first truly large-geared turbofan for wide-body jets. A gearbox lets the front fan spin slower and the internal turbines spin faster, letting each part work at its happy speed. Pratt & Whitney had shown that geared fans could deliver huge efficiency gains on smaller jets, but scaling that up to a 100,000-pound thrust monster engine was a whole different challenge. It would have been the aviation equivalent of taking F1 hybrid tech and trying to bolt it into a semi-truck. Third, a promise of long-term efficiency leadership. Rolls-Royce argued that while GE would deliver a safe, steady design, Rolls would leap ahead by the mid-2020s. If Boeing chose them, the 777X could have become the most fuel-efficient twin-engine aircraft ever built. The problem wasn't the ambition, it was the calendar. In 2013, Rolls-Royce's breakthrough technologies were still years away from flight testing. Some of the parts hadn't even been manufactured at full scale. Boeing couldn't risk betting a $50+ billion program, and its reputation, on an engine family that wasn't ready yet. Worse, Rolls was already dealing with technical issues on another major engine program, the Trent 1000, used on the Boeing 787. Airlines were grounding planes. Regulators were watching closely. Boeing saw this and worried. If Rolls was struggling with an engine that already existed, how could they confidently deliver an engine that didn't? So Rolls-Royce had vision, but Boeing needed reliability. And that opened the door wide for GE, who arrived with something Boeing found far more comforting: a giant, simple, powerful engine that built on a proven formula. While Rolls-Royce came in with a moonshot, GE showed up with something much more down-to-earth: a big, powerful engine built on a blueprint that had already succeeded for almost 2 decades. GE wasn't trying to reinvent the wheel. They were scaling up a wheel that airlines already trusted. Here's what made GE's offer so attractive to Boeing. First, a proven design philosophy: the bigger fan strategy. GE had been using the same basic approach since the GE90 in the 1990s. Huge fan, high bypass ratio, composite blades, and a simple 2-spool core. It worked so well that the GE9115B became the world's most powerful jet engine and powered the 777-300ER into becoming a bestseller. So when GE said, "We can build you a bigger, more efficient version," that wasn't a gamble. It was like asking a championship team to run the same playbook that already won them trophies. Second, fewer moving parts means fewer risks. Unlike Rolls-Royce, GE didn't use a gearbox. Their 2-spool design meant fewer components, fewer potential failure points, and, honestly, simpler maintenance. For Boeing, already juggling delays on multiple programs, simpler was a magic word. If Rolls-Royce's engine was like introducing a complicated new hybrid system in a car, GE's approach was more like upgrading the same V8 that everyone already knows how to repair. Third, GE had the supply chain and the scale, and really, this part is massive. Because GE already powered most of the 777 fleet, airlines had mechanics, spare parts, and maintenance centers built around GE's ecosystem. Choosing GE meant no retraining hundreds of mechanics, no new spare part warehouses, no redesigning maintenance schedules, and no delays waiting for new certification processes. Airlines could slide into the 777X with minimal disruption. From a business perspective, that's priceless. Fourth, the GE9X could be ready on Boeing's timeline. While Rolls-Royce needed years of research and development, GE could begin building and testing earlier. and with the 777X expected to enter service by the mid-2020s. In theory, Boeing couldn't afford a repeat of the 787 delays. GE simply promised fewer unknowns, lower certification risk, and faster integration into the aircraft. For a program worth tens of billions of dollars, this was Boeing's version of taking the reliable option instead of the experimental one. Fifth, Boeing liked having a single engine supplier. This is something airlines complain about, but Boeing liked it. One engine, one certification path, one integration process. No splitting resources, no negotiating separate contracts, no engineering the wings around two different engines. It just simplified everything. In short, GE wasn't pitching genius, they were pitching certainty. And when you're trying to launch the world's largest twin-engine jet, certainty can be more valuable than revolutionary tech. But the business side was equally important, because behind the engineering, there was a financial deal that heavily tilted the playing field. Behind all the engineering talk, Boeing's final decision wasn't just about turbines and materials, it was about business. Engine deals in aviation are like long marriages. The real money isn't made on the wedding day, it's made over the lifetime of the relationship. And GE understood this perfectly. GE offered Boeing an exclusivity deal, and Boeing loved it. GE didn't just propose building the engine. They proposed becoming the only engine supplier for the 777X. For Boeing, that meant one partner to manage, one set of tests, one aerodynamic model, one maintenance ecosystem, and no competition-induced complications during certification. From a manufacturing standpoint, it simplified the entire aircraft program. For GE, exclusivity guaranteed decades of revenue. Every 777X sold anywhere in the world would create profit for GE long after the original engine delivery. It was a win-win, but only if Boeing agreed to lock out Rolls-Royce entirely. GE was willing to invest heavily up front. GE put real money on the table. They co-funded major parts of the GE9X development and committed to sharing flight test risks with Boeing. That lowered Boeing's early financial exposure at a time when the company was juggling multiple expensive projects. Rolls-Royce, meanwhile, would have needed more time and more funding to finish developing its new technology. Boeing didn't want to carry that burden. The aftermarket goldmine engines make more money after they're sold. This is the secret of the engine business. Manufacturers make far more money servicing engines than selling them. A typical wide-body engine might sell for $25 to $30 million, but over 20 to 30 years of flying, it can generate $50 to $60 million in maintenance revenue. Boeing knew this. GE knew this. And GE was perfectly positioned because they already had the largest global MRO network, decades of 777 engine experience, and airline loyalty built around the GE90 success. By choosing GE, Boeing could tell airlines, your maintenance and reliability won't be disrupted when you upgrade. That pitch is incredibly persuasive to major carriers. Airlines quietly preferred GE. On paper, airlines always like having multiple engine options, more competition, better pricing. But behind the scenes, major 777 operators already had huge GE investments. Emirates, Qatar Airways, British Airways, Cathay Pacific. Training, tools, spare engines, all GE. Sticking with GE meant their transition to the 777X would be painless. Switching to Rolls-Royce would have required massive changes across entire fleets. Boeing listened to its customers. GE simply fit better. Timing killed Rolls-Royce's chances. Even if Rolls-Royce had matched GE on performance, Boeing still needed the engine quickly, the risk low, the cost predictable, and the airline feedback positive. Rolls couldn't check those boxes in 2013. GE could. So the deal was made. GE would power the 777X exclusively. Rolls-Royce was out. But this story doesn't end there, because what happened after the decision revealed how much both companies would pay for their choices. At first, Boeing's choice looked perfect. GE got the contract, Rolls-Royce moved on, and the 777X program began rolling forward. But then reality hit, and it hit harder than anyone expected. GE's safe engine ran into unexpected problems. Remember how GE promised lower risk? Well, the GE9X still turned out to be one of the most complicated engines GE had ever built. During early testing, engineers found turbine durability issues, fan blade wear, and higher than expected internal temperatures. One problem was so serious that GE had to redesign the engine's compressor, a fix that caused massive delays. It's like building a skyscraper and discovering halfway that the elevator shafts were too narrow. Everyone involved suddenly realized safe didn't mean easy. The 777X itself ran into certification delays. The engine wasn't the only issue. Boeing was still dealing with the aftermath of the 737 MAX crisis. Regulators were stricter, more cautious, and far less willing to approve anything quickly. As a result, test schedules slipped, certification timelines stretched, airlines pushed back delivery dates, and Boeing burned billions in development costs. Today, the 777X is running nearly a decade behind its original schedule. Ironically, the very thing Boeing tried to avoid, delays, happened anyway. Rolls-Royce's gamble looked terrible at first, then brilliant. When Boeing rejected Rolls-Royce, it looked like a huge loss. They were out of one of the biggest wide-body programs of the generation. But here's the twist. Rolls-Royce used the rejection as fuel to pour focus into its new engine tech. And by the late 2010s, the advanced core proved viable. The UltraFan gearbox worked. They achieved the world's largest geared turbofan test, and fuel efficiency targets were exceeded in demonstrations. Suddenly, Rolls-Royce wasn't behind. They were ahead. While GE's GE9X was stuck in redesigns, Rolls-Royce's experimental programs were hitting milestones that, while too late for the 777X, positioned them strongly for future next-gen aircraft. Boeing ended up with fewer options. By choosing GE exclusively, Boeing lost a bargaining tool, competition. With no rival engine for the 777X, GE controlled the pace, GE controlled the pricing, GE controlled the aftermarket, and Boeing had less negotiating leverage. And when problems hit, Boeing couldn't switch suppliers. They were locked in. In hindsight, exclusivity saved short-term complexity, but cost Boeing strategic flexibility. Airlines became frustrated, not at the engines, but at the delays. Major customers like Emirates and Lufthansa had ordered the 777X, expecting deliveries in the early 2020s. Instead, they faced multiple delays, uncertain timelines, rising costs, and aging previous generation fleets. Some carriers even downgraded or postponed orders. The 777X went from a next-decade flagship to a plane nobody knows when will arrive. So who won the long game? It's complicated. GE won the contract, but suffered painful engineering setbacks. Boeing got a reliable partner but ended up with huge delays. Rolls-Royce lost the bid, but positioned itself strongly for the next generation of ultra-efficient engines. The 2013 choice didn't create a clear winner. It reshaped the competitive landscape. Now we arrive at the final part of the story: how this decision affects the future of aviation, and why the Boeing GE versus Rolls-Royce split could influence the next 20 years of long-haul travel. The 2013 engine choice didn't just shape the 777X, it set off a chain reaction that will influence the next 20 years of wide-body aviation. Boeing, GE, and Rolls-Royce all walked away from that decision with different strengths and different scars, and those lessons will shape what comes next. Rolls-Royce is now ahead on the next big leap-geared fans for wide-bodies. The UltraFan isn't just a science project anymore. Rolls-Royce has already spun a full-scale demonstrator and proven that a massive geared fan can work. Ceramic materials can survive extreme heat, and efficiency gains of 10 to 15% beyond today's engines are real. And here's the key: the geared turbofan architecture is now seen as the likely future of long-haul engines. By choosing not to rush the technology for the 777X, Rolls-Royce may have accidentally positioned itself perfectly for the next major aircraft, a Boeing or Airbus clean sheet design in the 2030s. They lost the 777X battle but set themselves up for the next war. GE has the world's biggest modern engine, but needs a new direction. The GE9X is an engineering monster, the world's largest fan, the highest bypass ratio ever built, and the most advanced composite materials used in any wide-body engine. But it also forced GE to confront a tough truth. They can't rely on incremental improvements forever. Competitors are pushing toward geared designs and hybrid architectures. Customers want lower emissions. Regulators want quieter aircraft. GE will need to innovate more aggressively if it wants to stay dominant. The GE9X was the peak of the bigger fan, simpler layout philosophy. The next engine may require an entirely new playbook. Boeing now faces a critical choice for its next clean sheet aircraft. Because the 777X is so delayed, Boeing's next all-new plane, often called the new mid-market airplane or the new widebody, becomes incredibly important. And this time, Boeing won't have the luxury of picking the safest engine, locking out competition, or betting on existing technology. The world has changed. Fuel efficiency, emissions, noise limits, and sustainability targets are forcing aerospace companies to adopt newer designs. For the first time in decades, Boeing may have to choose between a next-gen GE design, Rolls-Royce's UltraFan family, or Pratt & Whitney's large geared fan concept. The 777X experience, both the good and the painful, will heavily influence that decision. Airlines want more engine competition, not less. Airlines have been clear. A single supplier engine deal is too risky. After seeing the 777X delays, carriers would prefer at least two engine options, more pricing flexibility, better long-term maintenance leverage, and less dependence on one manufacturer. This means Boeing may be forced to reverse its exclusivity habit for future programs. The next big Boeing aircraft is very unlikely to be a single-engine option airplane. The 777X may still succeed, but its role has changed. When Boeing first announced the 777X, it was supposed to be the future backbone of long-haul fleets. But now, twin-engine wide-bodies are getting smaller, airlines prefer flexibility over maximum size, and environmental pressures favor lighter, cleaner jets. The 777X will still serve mega-hubs like Dubai, Frankfurt, and Doha, but it may not dominate the way the 777-300ER did. Its legacy may be defined less by sales numbers and more by the lessons it forced Boeing and GE to learn. The real takeaway is that the 2013 decision wasn't just about choosing GE over Rolls-Royce. It was about betting on a certain vision of how aviation should progress. Slow, steady, safe, predictable. A decade later, that bet looks both smart and limiting. GE delivered a powerful engine, but one that pushed their old philosophy to its limits. Rolls-Royce missed the 777X, but leapfrogged ahead in future tech. Boeing avoided risk, but walked straight into a different kind of trouble. Long delays, no engine competition, and a challenging future market. In aviation, timing matters as much as technology. And the 777X engine story is the perfect example of how a single choice can ripple across an entire industry for decades.